All right, we're using linearization. Now, we got this cat named Roger. And I don't know about Roger. I'm kind of concerned about Roger because Roger is in a hovering helicopter and he's dropping one of his shoes. Now, I don't know how many times you've been in a hovering helicopter, but I hope you've not dropped your shoes. If you're in a hovering helicopter, I would advise keeping your shoes on. But this is not what Roger did. He dropped one of his shoes out of this hovering helicopter. Now, we got a table here where D is the distance in feet that the shoe has dropped after T seconds. So time, we got time measured in seconds, 0, 1, 1.5, 2, 2.5, 3, 4, 5. And D is the distance that the shoe dropped after so many seconds. 0, 15.7, 35.4, 63.8, 101.4, 144.5, 258.1, and 404.8. He was over 100 yards high when it dropped in 5 seconds. Find the quadratic model. Now we know when we got the quadratic model, what are we going to do with y? We're going to use the square root of y for our linearization to linearize that data. And then it says find the linear regression equation and then use that model to predict the distance the shoe has traveled after 7 seconds. Well, let's move to the calculator and let's do our linearization. Let's linearize the data and find our linear regression equation. All right, here we are on the calculator, and you can see I've already entered the data for L1, time in seconds, L2, the distance in feet that poor Roger's shoe dropped. And now we are going to go ahead and, while we're here at the table, I'm going to go ahead and linearize the data by taking the square root of y. I highlighted L3 at the very top. I hit second x squared, which gives me the square root, and I want the square root of L2. So I hit second number 2 for L2. And then we're going to hit enter, and shazam, it's taking the square root of all of those values in L2, which is the distance in feet. All right, well, let's see. Let's check our stat plot before we go look at our original scatter plot. And it's on, but I want to change this X list and Y list. Excuse me. Let's see. Let's change it. Let's see what our data looks like in its original form. So I'm going to go to L1, put X list at L1, and then put the Y list at L2. And I'm going to hit zoom 9, zoom stat. And I guess it's got some of the elements of a quadratic. It starts right here at 0, and it's got this curved slope. It looks like a parabola, half a parabola. All right, now let's do our stat plot with our linearized data. So I'm going back into stat plot. And what I'm going to do is I'm going to change the Y list to L3. So it's second number of 3. That's L3. We're going to enter through here. And now let's go look at our graph. I'm going to hit zoom static again. Yeah, and it looks pretty linear. So why don't we get our linear equation, regression equation. So I went to stat. I go to calc. I'm going to choose option 4. Let's see, and I need my X list to be L1, so I need to change that. So L1. And I want my Y list to be that linearized data, which is in L3. So I'll change that. Now enter, 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 enter. Let's see, and we got Y equals A 4.03 X plus, no, excuse me, negatives minus 0.05. Well, there's our linearized data. Okay. And I don't think I'm going to draw the line of the linear regression. We have our linear regression formed. So let's go over here and let's convert that back to a quadratic model and finish this thing up. All right, so here we got our linearized data. We got, and that should have a little caret over top of it. Let me draw that in there to designate that this is our linearized data. 4.03x minus 0.005. Now, we took the square root of y, or actually d for distance, and so building that quadratic equation, 4.03 squared, you know what, I'm just going to round that to 4, as you see already here, and then I got negative 0.005. If I square 0.005, it becomes 0.0025. So I'm just going to leave it at 0, and I'm going to set my my quadratic model back to the square root of d equals 4x squared. And then, of course, we're going to square both sides of this. And when we do, then this is going to become d is equal to 16x squared. So 4x squared becomes 16x squared. And so that could be our quadratic model. Now, we were also asked to predict how far it's going to drop after 7 seconds. Well, I can just substitute in 7 for x, since this is not a very lengthy or complicated equation. And so the distance then is going to be equal to 16 times 7 squared. And of course, 7 squared is 49. So let's see, 16 times 49. And we would predict that when poor Roger, dropping his shoes out of a hovering helicopter, after 4 seconds, his shoe is going to drop 784 feet. I hope he gets his shoe back. You'd be better off to drop 2 shoes, wouldn't you? Rather than 1. I mean, you can't wear 1 shoe. You got to have 2 shoes. If I lost 1 shoe, I got to buy a second pair. I got to go ahead and buy another pair. I might as well just drop 2 shoes. I don't know what's wrong with Roger.